Introductory trial video. First thing I'm going to try posting on my YouTube channel. This is an introduction to aqueous reactions trial run, and we're picking up, having already discussed the importance of water. They're very important. The world is about 2/3 water. We're about 2/3 water, and the reactions that take place throughout the world and in our bodies largely occur in aqueous solution. So understanding them is very to his. Let's start with this. In class, in person, do this in a visual way on the slides. I have a solution of lead 2 nitrate. It's lead 2 nitrate dissolved in water. Formula is shown, PbNO32. AQ stands for aqueous. Similarly, potassium iodide, Ki, and note that both are clear and colorless solutions. But if we mix them together, what happens is a yellow, thick, cloudy substance forms throughout, and if we wait a while, we'll see that this substance gets kind of fine and powdery and settles to the bottom of the beaker that it's in. So the question is, what's going on here? Can we describe it in a chemical manner using a chemical equation, figure out what's going on? And of course we can if we think about it a little bit. So this is example 1. For starters, we have lead 2 nitrate aqueous. We're combining it with potassium iodide aqueous, and it makes some thick, cloudy yellow stuff. And the question is, what is that? And what, if anything, might the other product or products be? Well, jumping ahead a little, some of you might be able to figure this out, but it turns out that the lead 2 plus ion from the lead nitrate combines with the iodide ion from the potassium iodide, and that compound that forms is that thick, cloudy yellow stuff. So as a little check of previous understanding, here are some possible formulas for that lead iodine compound, and determine which one you think it is. And you might want to pause if you need a chance to think, because in just a second the answer that's correct is going to come up. And the substance is, of course, PbI2. Of course, you need 2 negatively 1 charged ions to balance off or end up forming a neutral compound with 1 positively 2 charged lead ion. So the formula would be PbI2, 2 I's for every 1 Pb. If you didn't get that right, you may want to go back and review balancing of ions and forming formulas for ionic compounds. And why not one more question? The compound it might be, or of course none of the above. You might want to pause if you need time to think, because the answer is going to appear momentarily. And it's, of course, lead 2 iodide. Don't forget that if the compound is something like lead, that's a transition metal or in the middle-ish of the periodic table, where it's hard to know for certain just based on its location in the periodic table what its charge is, we need to specify that charge. We don't need to specify the charge of iodide because we know it's going to be -1. And again, if you got this wrong, you may want to go back and review a previous lesson on names of ionic compounds. Okay, so now back to our example. Here's, we're going to call this example 1. We know that PbNO32, lead nitrate, lead 2 nitrate, reacts with potassium iodide, and one of the compounds that's made is lead 2 iodide, PbI2, and note we put a parentheses S here, as we've talked about before, to this symbolizes that it's a solid. Now it turns out, again jumping ahead maybe just a little bit, that the other product is potassium nitrate, KNO3, and it turns out that's clear, colorless, dissolved, fully in solution, and so we put AQ there. And substances, and you might notice that the equation wasn't initially properly balanced, but by putting a coefficient of 2 here and there, it now is. You need to start with 2 K's and 2 I's if you end up with 2 K's and 2 I's. Like this, where we start with aqueous solutions and form a solid in the process of reaction we call precipitation reactions, and the solid that's formed is known as a precipitate. It's an insoluble solid, and it precipitates or falls to the bottom of the container that it's in, hence the name. And these are my cheesy little pictures that help me visualize what's going on. Lead nitrate in aqueous solution you can largely think of as some lead 2 plus ions and some NO3 2 minus ions in a whole bunch of water. I'm only showing one of each ion. Of course, there'd be many, many, many more, and there'd be 2 NO3 minus ions for every one Pb2 plus ion. But here, all I'm trying to indicate is what are the substances, not the numbers of them. Same idea for Ki, potassium iodide. The solution would contain potassium ions, K+, and iodide ions, I-, and lots and lots and lots of them. Mix the two solutions together. Remember that these ions are free to move about throughout the solution, and you might notice that Pb2 plus ions from the lead nitrate might possibly attract to the I- ions from the potassium iodide. Similarly, K plus might attract to NO3 minus, and so possible products are the combinations of lead 2 plus with I minus or K plus with NO3 minus. It just so happens that the thing that is the actual solid is lead iodide, and the potassium nitrate turns out to be soluble. So how we choose to write that, PbI2 parentheses S, is the product that's visible, the yellow stuff that falls to the bottom, and then we associate the K plus and the NO3 minus together as an aqueous solution, even though those ions are, of course, really not stuck together in actual fact. And now we notice, of course, we need to balance. As before, you need a 2 in front of the potassium iodide and a 2 in front of the potassium nitrate. And then one further visualization of how you might sort of see this. Now I'm putting in the right numbers of ions of each thing and allowing them to mix together, and they'll move around bit by bit. And as lead 2 plus ions encounter iodide minus ions, they'll stick together in a 2-to-1 ratio and settle to the bottom of the container. The K plus ions and the NO3 minus ions, potassium and nitrate, don't stick together. They stay in solution, but they balance each other out and overall give a net neutral charge to the solution. Okay, so we've talked about how to name ionic substances before, ionic compounds. So a little quiz question for you: which are the correct names of the two? And again, pause this if you need to think about it a little bit. And then the answer comes up. It's F, silver 1 nitrate and sodium phosphate. I will note silver so typically forms the +1 ion that you'll see it both ways. You'll see silver without the 1 nitrate. All right, and then here's now the next thing, example 2. We're going to do a reaction of silver 1 nitrate or silver nitrate with sodium phosphate. Here are the two substances, and it turns out when they're mixed, it makes a precipitate. It's a precipitation reaction, and your task is to see if you can figure out what the two possible products are, and then get their formulas right. And then we'll talk in the next lesson about how to determine which one is the actual precipitate, so you can figure out what the compounds formulas you think should be, and then I'll reveal the answer for you to check yourself with. What they could possibly do, as before, not balancing the amounts, because that's one of your tasks, but Ag is plus, PO4 is 3 minus, so another clicker question for you, or quiz question for you if you need time, and then the answer will be revealed now. You need 3 silver ions to balance off each phosphate. And then one more chance to remember that they combine with each other. There's one possible product, and again, combine with each other, second possible product, and it turns out the silver phosphate is the solid, the sodium nitrate is the one that's aqueous, more on that later. And then of course you might notice not balanced now, pause if you want to think about how to fix it. And then here's how you do. You of course need a 3 and a 3. All right, that's called the molecular equation. We'll talk about another way of writing things called the net ionic equation and the overall ionic equation next, as well as how to determine which of the products, if any, forms a precipitate. So hope that's a useful lesson, and we'll post it to YouTube and see how things